I'm Ramu, and I'm here with my colleague Denise, and Rahul will be joining us throughout the presentation to go over a few demos. We're from the Oracle Spatial and Graph Product Management team, and we're very excited to talk to you today about Oracle Graph, which is part of the Oracle database, and how it helps simplify application development using SQL property graphs.
Before we get into why Oracle Graph can help you build modern data-driven applications easier and faster, let's talk about a scenario. Here we have Oragram Book. Oragram Book is a fictitious social media platform. They are a new company and want to enhance their user experience by ensuring users can find and interact with their family and friends easily. This will help keep their users happy and attract new users to this social media platform. But what does this new user experience look like? Tom is new to Oragram Book. He makes his first post. It's a picture of himself. Hi, Tom. Then Tom finds his friend Strike and follows him. Strike has 2 posts in his profile. Now Strike realizes that Tom has joined social media after saying he wouldn't and follows him back. The two of them start engaging with each other's posts. Tom likes both of Strike's posts, and Strike likes and comments on Tom's new post. Then Tom finds his other good friend Gawker. The dynamic looks simple to follow and understand when there are only 3 people involved, but Oragram Book wants to grow a lot more. Let's increase the number of users to 10. We see more posts and more interactions. We want to help our users connect faster and easier with their family and friends. How can graphs help us do this? For example, I would like to see if there are any connections between Tom and Harry, and if I should recommend Tom to follow Harry.
Of course, this is starting to look like a graph, and it is a great example to explore the power of graphs. We have our users represented as entities and a lot of connections between those entities. In property graph data model, a set of vertices are representing the entities, in this case users and posts, and edges are representing the connections between those vertices. In this case, it would be follows, likes, and creates. Here we can see how we can use graph to explore and traverse relationships in ways that would be more difficult to do otherwise. So to your first question, Denise, is Tom connected to Harry? The short answer is yes, but not directly. It is through other users. Let's see if Harry would be a good user to recommend to Tom. So from what I've heard, Oragram Book wants to recommend people follow users connected indirectly within reason. Let's say they want to look for people 1 to 5 connections away as a requirement or business rule. So let's find out if we should recommend Harry to Tom, meaning is Harry a friend of 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 Tom, or somewhere in the middle? And as we can see in this graph, he's 5 connections away. So to answer your second question, yes, Harry is a good recommendation for Tom. You might be wondering, can we traverse these connections through SQL? And the answer is also yes. Let's look at how Graph and SQL come together and how with Oracle Database 23C, you can write SQL queries in a shorter and more straightforward way. So in the left, we have a SQL model for our application where the data is represented as a graph. And on the right, we have our graph model, which transforms our tables into graph. While some people might look at the left-hand side and know how the data is connected very easily, the graph representation could be much more intuitive, especially when we need to traverse across multiple tables.
I could see how this would benefit SQL users because it helps them write simpler code. Are there any other benefits to using graphs?
In SQL, before Oracle Database 23C, traversing relationships across multiple tables would require lengthy and complex joins. But now we can simplify the traversal to a simple SQL property graph query. At Oracle, one of the ways we create graphs from database tables is by using a create property graph statement. So continuing with the Orogram book use case, we have two tables. One is users, which has the user's information where the ID is the primary key, and the other table is followers, which has a report of all follows between accounts, where follower ID and followed ID are foreign keys, referencing IDs in the users table. We can create a graph where the users are the vertices and the followers are the edges.
So here we can see we are transforming these tables into vertices and edges that are components of a graph. I am sure that people are interested in seeing the SQL syntax on how to query these graphs now that we have the new release of 23C.
Yes, let's cover it. So using SQL, we would write something like this to figure out if Harry and Tom should be recommended friends. And obviously, this is a pretty long and complex query to write. However, using graphs, we can simplify this to only a couple of lines. In here, the new way of writing this query using SQL 2023 and Oracle Database 23C is being shown. Isn't this much more straightforward? If you're using a database 19C or earlier, you can use property graph query language to write similar queries. Both the property graph query language and SQL property graphs will be supported in Oracle Database 23C.
This is a noticeable difference in length. I also noticed that even though there's some new syntax being introduced, we can still understand what's going on in this query if we are comfortable with SQL. Can we have a look at another example?
Yes. So here we have a way of figuring out how, if Harry and Tom should be recommended friends. Obviously, again, this is a pretty long query to write. However, using graphs, we can simplify this to a couple of lines. So again, in here, we have using the new property graph standard of SQL 2023 that afford us a much simpler query. Let's look at this in real time. In this demo, Rahul will show you how we can easily create and query property graphs using application development tools that you may already be familiar with, starting with SQL Developer.
With SQL property graphs, we can create and query property graphs directly in a SQL Developer worksheet. Before we dive into any queries, let's first look at how we can make a property graph. Step 1. Create and load data into your tables. You may have existing tables that you want to use to build your property graph, but for this example, we've created tables in the social media schema that you saw in the slides and added the necessary primary and foreign key constraints. Step 2. Form and run the create property graph statement. Here you can see the create property graph statement where we specify the vertices, edges, and the ingoing and outgoing edge keys. Step 3, run some queries. So let's look at some examples that we have here. First, let's see if we can recommend that Tom follow Harry with the idea that recommended users are 2 to 5 follows away. And we can see that there's a match, so that means that we can recommend Harry to Tom. Second, let's see who we can recommend to Tom and exclude anyone who Tom might already be following. Third, let's see who Tom follows but doesn't follow Tom back. So as we can see from this demonstration, we can create and query property graphs using SQL and Oracle Database, which means we can run property graph queries using SQL tools that we know and love, like SQL Developer.
Companies are being placed under increasing pressure to stay competitive. They not only have to understand their customers, but they have to be able to anticipate their needs. The easiest way to do that is to become data-driven, or in other words, to take advantage of data-driven applications. When it comes to building data-driven applications, developers face a whole new set of requirements as they operate on diverse set of data, spatial, document, sensor, transactional, etc., being pulled in from multiple different sources, often in real time. The converged database is a modernized approach to data management. While traditionally, an IT department would need separate instances for each different data type of workload. The Oracle database puts it all under one roof. Oracle's converged database eliminates the data fragmentation introduced by multiple single-purpose databases by offering support for all data models and workloads in a single database. It also offers integrated support for all of the latest development techniques, like microservices, event stream processing, API-driven development, and even low-code development. And with its uniform SQL or REST APIs, developers can access any data model or value-generating technology without a steep learning curve. And of course, Oracle Graph is a part of the converged database, meaning you are also able to use it with all other Oracle tools like Apex. That allows you to develop and deploy compelling apps that solve real problems and provide immediate value. Raul, can you give us a demo on how to show how we can use Graph and Apex together to create data-driven applications?
Of course. Let me first start with doing some graph analytics with Jupyter Notebooks and then use Apex to access more information about users in Oragram Book. We can work with property graphs using Python through the Python Oracle DB library and then use this library to execute in-database queries. After connecting to the database, we can see that we can query the user property graphs table to see the graphs that we have available. We can run queries like we did in SQL Developer. In this example, we're checking to see if Tom and Harry are connected in 2 to 5 follows and see if Harry should be a recommended follow to Tom. We can use the graph server to run graph algorithms. For example, let's run a PageRank algorithm which will tell us the quantity of ingoing and outgoing edges for each node relative to other nodes. In this example, that can be used to determine possible influencers. As we can see, Blutch is our most likely influencer. So let's head over to our admin application in Apex and learn more about Blutch. Here we have an application where we can see more information about each user using in-database SQL property graph queries. So let's learn more about Blutch, like the number of likes on his posts, the number of comments on his posts, the posts he's liked, the posts he's commented on, and who he's following and who's not following him back. Lastly, we can see who is following him and who we should recommend to him. The Oragram Book admins wanted a separate page that we can check for the number of comments on each post by each user to easily check for potential spam commenters. Here we see a few instances where users left 2 comments, but always by different users on different posts by different users, so it's probably nothing to worry about. So, from the last 2 examples, we can see how SQL property graphs can be used with PGX to gain more analytical insights into the data, and how we can create low-code applications with Apex using short queries that would otherwise be difficult and complex to write.
Awesome demo. This is only one of multiple use cases of graphs. It can be used in financial services to detect fraud, in transportation to identify vulnerable points in infrastructure, or in telecommunications to analyze network topologies to identify the root cause of outages and more.
There are so many applications for graph technologies. Please reach out to the Graph team today to learn how we can help you find the hidden connections in your data. Thank you for joining us today for making the right connections. We hope you have a great time at Cloud World.